In the last section, we started looking at the spiral matrix problem. We're now going to continue by looking at some notes on a possible way to solve this. So let's take a look. So this is the general notation that we're going to use as we look at our solution. So the outer box here is meant to indicate the outer array, and then each of these inner boxes indicate the subarray that are inside of it. So this would be one subarray right here with the values 1, 2, 3. Then the next subarray is right here, and the final one right here. And then all three subarrays are contained within this outer array. So with that in mind, let's take a look at our diagram. All right, so this is a nasty thing right here, but it is a nasty problem. So I'm going to give you a kind of cursory description on the algorithm here. I'm not going to try to walk in great detail through every step right here, but if you want to look at these notes right here, remember you can always pause the video and take a glance at this diagram, or all the course's diagrams are inside of the accompanying GitHub repository, which was linked at the start of this course. And so you can always go back there and take a look at these steps right here. I would love to walk through all these steps verbally with you. However, if I start essentially reading these off, it gets really confusing very quickly. So, honestly, it's probably best that you might sit down and take a look at the steps here on how we might solve this. This solution is 100% predicated on this idea of maintaining some counter variables that reflect what starting column we are working on and what end column we are working on, along with the starting row and ending row. So the idea here is that we are going to have some integer values that keep track of the current index that we are trying to fill inside of our matrix. So we might start off with a start row equal to 0. And that means that when our algorithm first starts off, we want to look at row 0 and start attempting to fill values inside of that row. Then the last row that we want to be concerned with would be row 2 down here. Notice that these are not necessarily hard-coded values. I'm assuming that we have an n equal to 3 right here. So if we had n equal to 2 or n equals 4, 5, 6, whatever, this end row value right here might change. And so you're probably going to have to do a little bit of math to calculate exactly what the end row should be, depending on the value n that is passed into the function. The start column is going to be some counter of sorts that decides what value or what index we are currently trying to fill out for on the left-hand side. That will start off as 0, and then the end column will start off as 2 as well. So the general idea here is that we're going to make a series of for loops. So here's one for loop right here, here's one for loop right here, and then I did not show the other two for loops that you'll have to make on here. Inside of each of these for loops, you are going to iterate from some start column up to some end column. And for every value or every index between start column and end column, you will insert some value into the matrix. So for example, the very first loop right here, we'll iterate from start column to end column. So from 0 to 2. And then at every step throughout that loop, you will attempt to insert some value on this first starting row right here. After you have filled out this first row right here, or in other words, after this first loop has completed running, you can then increment this start row value. So we could increment start row by 1, and it would say, all right, this is now the first row that we want to be concerned with. So essentially, after you fill out the first row with 1, 2, 3, you don't worry about the first row anymore. You are now only concerned about this remaining part of the matrix. So now the start row right here would be equal to 1. You would be looking at this element right here, then fill this one out, and then you would decrement the end row to over here. And so essentially these starting and ending counters that we're looking at right here are going to be changing over time to essentially set the bounds of what portion of the matrix you're trying to look at any given time. These directions right here probably give a very good direction or a good idea to you of exactly how those bounds are going to work. So again, do look at the steps right here. Now the last thing I want to mention to you is that I highly recommend that you create the results set from the very beginning. And when I say results set, I mean the empty array of arrays. So build that at the very start of the problem and do not attempt to start to insert arrays as you are iterating through this thing. Much easier to build out the empty arrays at the very start and then insert numbers into that. Okay, so I know that this is a very tough problem. It really is very tough, but as soon as you see the solution, I know it's going to make a lot of sense. So I encourage you to give this a shot. Do the best you can, all right? Do the best you can. Come back in the next section and we'll walk through the solution. So quick break, and we'll take a look at this thing again in the next video.